right, in this video we're going to go over the warm-up for lesson 4.2. Now again, if you have not watched the video and taken notes on 4.2, please make sure that you do that. Don't think that just doing this warm-up will be enough to teach you what to do for this lesson, because there's a lot of new information in here. So you want to make sure that you know what you're doing, and the purpose of this is just meant to review the concept to make sure you're ready for your assignment. So let's go ahead and look at how to do this first problem. So in this first problem, we're asked to find both the vertical and horizontal asymptotes of this equation. So remember, what we have to do is to find the vertical asymptotes, we just have to factor the denominator, because we want to figure out what values x can't be in the denominator, because remember, the denominator cannot be equal to 0. And so the way that you do that is we're going to factor that down. So 2x squared, starting with 2x squared plus 6x, we always look for a greatest common factor first. And so both of those terms have a 2x in common, because both the 2 and the 6 are divisible by 2, and they both have at least one x. And so we'd factor out a 2x, and when we do that, 2x squared divided by 2x leaves us with just 1x. And 6x, when we divide by 2x, well, 6 divided by 2 is 3, and when we factor out an x, there's not an x left over. So we would have 2x times x plus 3. So what we're going to do, again, is we're trying to figure out what values x can't be in this fraction. And so we know we can't divide by 0, so anything that would give us 0 in the denominator would be something that we can't have in the domain. And so that means that that's where our asymptotes would be. And so our asymptotes would be, if we set each of those factors equal to 0, that's how we get those asymptotes. So 2x equals 0, x plus 3 equals 0. And when you solve those, we get x equals 0 and x equals negative 3. So you want to make sure that when we give an asymptote, we write it as an equation. So don't just say 0 and negative 3. What we do is we say x equals 0 and x equals negative 3 would be our two vertical asymptotes. Now we got to figure out whether or not we have a horizontal asymptote. Now remember, if the degree in the numerator and the denominator are the same, then your horizontal asymptote is going to be y equals whatever the leading coefficient of the numerator is divided by the leading coefficient of the denominator. So in this situation, and I'll talk about what happens if the degrees aren't the same when we look at the next couple of examples. But for this one, again, the degrees are the same. They're both 2. And so that tells me that the horizontal asymptote is going to be the leading coefficient of the x squared and the leading coefficient of the 2x squared. So it's going to be 1/2. All right. Let's look at number 2. So let's see how we could find the vertical asymptotes, if there are any, for number 2. So again, when we look at negative 4x plus 16, I would factor that down. Now, between the negative 4 and the 16, the greatest common factor is negative 4. If the first term's ever negative, you always want to just include a negative as your greatest common factor. So in this case, it would be negative 4. And then when we take and divide both of those terms by negative 4, you get x minus 4 left over. So we'd have negative 4 times x minus 4. Now, when we go to set these equal to 0, you only set the factors, and a factor we only get from an x. So negative 4, we don't get a vertical asymptote from negative 4 because there's no x there with it. So the only vertical asymptote we would get from the x minus 4. When we set that equal to 0, we get x equals 4. So your vertical asymptote is at x equals 4. Now for the horizontal asymptote, we look at the degrees. Okay, so if you notice, the degree in the numerator is 2, the degree in the denominator is 1. So they are not the same, and the degree in the numerator is, so if they're not the same, you need to look to see, is the degree in the numerator bigger or smaller than the one in the denominator? If the degree in the numerator is bigger than the degree in the denominator, there is not going to be a horizontal asymptote. So there's no horizontal asymptote for this one. There's only a vertical asymptote. All right, let's look at number 3. So number 3, it says, find the vertical and horizontal asymptotes of this one. And so, again, looking at the vertical asymptote, if we start there, the vertical asymptote we get from x squared minus x minus 6. We're going to have to factor that down. So this one, we have to look to see. So I noticed that first off, I noticed that our a value here is 1. We're going to be reviewing tomorrow, by the way, what happens or how to factor this down if a is not 1. But here a is 1. So we're going to use that shortcut where we would just have our first values would be x. And then I'm trying to find out what two numbers multiply together to be negative 6, that add together to be negative 1. And that would be negative 3 and 2. Or if you said 2 and negative 3, that's fine. So then we end up getting x minus 3 times x plus 2. So we set each of those factors equal to 0. And we end up getting our vertical asymptotes. That would be x equals 3 and x equals negative 2. Now for this one, you might be wondering, well, for the horizontal asymptote, what's the degree in the numerator? Well, we can think, so we don't have an x, so you can think of it as x to the 0 power. There's no x there. So the degree in the numerator would just be 0, and x squared would be, the degree of that would be 2. So here the degree in the numerator is smaller than the degree in the denominator. So as a result, if that ever happens, then the horizontal asymptote would be y equals 0. Okay, so you want to make sure that you know those 3 scenarios for the horizontal asymptote. Now, I really don't care for these last 2. The best one of these last 2 is number 5, but we should have given you better graphs to be able to graph these better. The key is, let's make sure we know how to find the vertical and horizontal asymptotes and how to graph those. That's kind of the key here. And then we'll talk about how to get the actual graph of the function here in just a minute. So for the first one, for the vertical asymptote, again, we look at the denominator. The factor in the denominator is x minus 1. If I set that equal to 0, I would get x equals 1. And so x equals 1 would be a vertical line going through where x is 1. So make sure you understand that. So that's how you get that first vertical line there. Now for the horizontal asymptote, I notice that the degree for both of those are both 1. Okay, so this has a degree of 1, this has a degree of 1. And so since they have the same degree, that means your horizontal asymptote is going to be y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. So it would be 2 divided by 1, which is just 2. So our horizontal asymptote, so we'd have a horizontal line going through where y is 2. So those are our 2 asymptotes. So that's important to know how to graph those. Now, how do we get the actual graph? So there's a couple ways we could do that. One way would be by creating a table. So I know that as far as what values to pick for x and y, I'm going to pick values for x that are close to that vertical asymptote. So I'm going to use 0 and negative 1. So that'll give me a graph in that quadrant. And then I would use 2 and 3. So that'll give me a graph. And at this point, I wouldn't know if it's in this quadrant or this one for that second part, or if it would be in those 2 quadrants for the left side. So at this point, we wouldn't know. So the way that we would tell is by, again, using negative 1, 0, 2, and 3. I didn't put it in that order. I put 0, negative 1, 2, and 3. I put it in that order. But when you put those values in for x, so we're putting those in for x in this original equation, we get negative 8, negative 4, 12, and 7. So when you graph those, again, it'd be really hard in the top right quadrant to figure out where that would be. You just kind of get an estimate of what that graph would look like. But their 2 branches would be in those 2 locations, in the top right quadrant or region and the bottom left region. All right, let's look at the other one. So the other one, our denominator, we just have x minus 1, so we'd set that equal to 0. Again, we'd have a vertical asymptote at x equals 1. And then our horizontal asymptote, notice again, the degrees are the same. They're both got a degree of 1. So then the horizontal asymptote would be y equals 3 over 1, which is just 3. So we'd have a horizontal line going through where y is 3. Now this one is a little bit easier to graph. Again, as far as which values we want to use for x, we want to use values for x that are close to this vertical asymptote. So I would use negative 1 and 0 and 2 and 3. And when you plug those in, again, we're plugging those into the original equation for both of our x's there. You get 9 halves, 6, 0, and 3 halves. So 9 halves is about 4.5, and 3 halves would be 1.5. So if we just graph those points, then we can sketch a graph of what those 2 branches would look like. And so they would be in the top left quadrant and the bottom right quadrant. All right, so that is how you do that warm-up. So hopefully you, after watching this and trying that on your own, hopefully you did a good job on that. Otherwise, good luck now as you work on your assignment for lesson 4.2.